Hey guys, welcome back to the channel. My name is Aman Singh and I will be discussing on a new topic today, root name server and top level domain name server. I have already created one video related to DNS. You can go and watch that video, and I have covered some topic of DHCP. Just watch that videos. Okay. So let's start this video. Let's discuss the diagram. So consider this user is sitting at his office and he's trying to reach to this server, and he's trying to reach to this website www.pingpacketlab.com. So in this scenario, what will happen? The client request, uh, client types this URL in this browser. This browser can be any browser, Firefox, Mozilla, Internet Explorer, or Safari. In the browser checks his history. Is there any kind of entry for this domain and name? If no, so it goes straight away and check the host entry. If in the host entry, is there any kind of manual entry created for this domain name? Check that part. If it doesn't find it, then go straight away to ISP resolver or DNS server, whichever you have configured. ISP resolver is nothing but the DNS servers provided by your ISPs. Okay, and there are Google DNS servers also, which you can configure it on your PC in your network environment also. So if these servers are having any kind of cache entry for this domain, if yes, then take the IP address and send it back to the client, and then the client directly request goes to the server. But what if this ISP resolver and Google DNS doesn't know about this URL public IP address? Then what they do, they send this request on behalf of client to the name server. Okay, the name server is nothing but the root name servers. So let's discuss this. What is root name server? So in the hierarchy, it is the top the top level. They don't store any website IP record, but they can help to identify which server top level domain server is can which top level domain server can help to find this IP address. So basically they know this server, they redirect the query to another server. Okay, so basically there are 13 set of root server. If you see, so if you see, these are the 13 root servers, and they are starting from A to M, A till M if you count this root servers. So that these are total 13 root servers, and these are generally taken care by very big organizations like VeriSign, ICANN, NASA. Okay, so these root servers are like generally these are not only 13 in the worldwide. There are around 100 of physical servers. Okay, they are not just the 13. So in the worldwide, it is like you can find 100 of physical servers where this they are acting as a root servers, and if one of the root server goes down, then the request can be taken care by other root servers. So generally what happens in background is generally the root servers are uses the Anycast. Okay, so Anycast is nothing but where the same IP address we can assign it to the multiple server in the backend. Okay, one server, whatever the IP address is having, the same IP address can be used by other 100 servers also. So not we have only 13 in the backend, like there are hundreds of physical servers placed worldwide, and they do the same job. Okay, to check the query and reply the query. Okay, if one of the root server goes down, or if one of the root server is under attack, then also there is no outage or like issue, because there are other root servers also which can uh, which can reply to that query. So in it is like there is a redundancy. If one of the root server goes down, there are other root servers also present. Just the thing is like if your query goes to that root server which is offline now, then the query will be redirected to the another nearest root server. So the routing decision, as per the routing decision, whichever the root server is nearby to you, they will answer your DNS query. Okay. So this reduces delay and ensure that if one of the server is unreachable, another pick up and do the job. So let's come back to the topic again. And also if your this root servers goes down, so there is no need to panic because the ISP resolvers, they generally have this uh, in the cache entry. So instantly we won't be seeing any kind of outage or any issue, but these are already working as in a form of redundancy, so it won't create any issue. So let's move to the next topic is top level domain name server. We call it as a TLD. What is TLD? So if you see that website name www.pingpacketlab.com, so this website is basically, if I divide into, if I divide this dot, so dot, the URL, if you are seeing, it is ending with com, but it is not like that. There is a back in the end, there is a dot also, which generally specifies that it is, it should, this request should be going to the root servers, and the next thing is like .com. So right now my domain is like listed under the .com. If I would have could have listed in inet also, .org also, and if country specific also, like .in, .us, .uk also. Okay, so these are the top level domain servers, and this is the actual domain pingpacketlab.com. So once what happens, the request comes to the root name server, then the root name server redirect the request to top level domain name server. The top level domain name server will check, okay, is there any domain name, is there, do you guys remember having any idea who, what is the IP address for this domain? So the top level domain name check in their database, and they redirect they reply the query with the respective authoritative DNS server, which can help you, which can help to get this IP address. Okay, so authoritative DNS server is the actual DNS server which have the A record, where the actual detail mapping of the public IP and the domain name. Okay, so after the query reaches from to finally a DNS server, so the DNS ADNS server is the final stop, and they generally have the idea of this IP mapping, and they reply back the request, they reply back with the public IP to the ISP resolver. And these ADNS generally have multiple records, like A record, which have generally mapping of FQDN and IP address, MX record for email. Whenever we type an email and send that email, that record also, we, it is created on ADNS servers only, and TXT record, PTR record. So it is the final stop. So now the request gets reply back, and the resolver now get the IP address of this domain, of this website. Then the resolver, what it does, it stores in its cache entry, and then it sends back to the client machine, and the client machine is now he will be able to reach to this website. Okay, so yes, I have let's end this topic here. Thank you for watching. Like and subscribe, guys, if you like this video. Bye.